Today, we will be talking about this report, which aims to explore two different experiment types, one correlational and one control, being from two different science fields, chemistry and earth sciences. The reaction between hydrochloric acid and calcium carbonate can be represented by this equation. This reaction is notable for producing carbon dioxide gas, which can be used to understand reaction kinetics and the effects of varying reactant concentrations. Real-world practical applications of this reaction include industrial cleaning, where hydrochloric acid is used to clean calcium carbonate deposits. It is also used in testing calcium carbonate in antacids to design effective treatments. Also, industrial CO2 production and acid neutralization in wastewater treatment. The angle of repose is a physical property that describes the steepest angle of a pile of granular material represented in Figure 1. Understanding this angle of repose can help with insight into a material's properties and has practical implications in fields of engineering, geology, and etc. Our experiment of the angle of repose was to measure it under certain conditions to see how the materials would be influenced. Conditions such as restriction on the diameter, therefore testing the different diameters effects on certain materials such as dirt, sand, and pebbles. For the calcium carbonate and hydrochloric acid reaction, the only changing condition was the temperature at which the reaction occurred.
Okay.
Start now.
Knowledge of science. So, the first controlled experiment manipulated the independent variable of temperature to measure the dependent variable that was the rate of reaction of hydrochloric acid with calcium carbonate. This was done to understand the causation and effect the independent variable of temperature had on the dependent variables. While theories and possibilities were discussed before performing the experiment, the true results could not have been predicted as easily due to the controlled nature of the experiment. The second investigation was a correlational study, which, unlike controlled experiments, does not explore causality and only shows more simple association between variables. With this particular study, the correlative nature of the variables made it easier to predict the outcome to be an equal ratio without actually experimenting using only research and prior knowledge of trigonometry. The research questions constructed for both of these tasks were as follows. The first one, how does the temperature of hydrochloric acid affect the rate of reaction with calcium carbonate and the mass of CO2 lost during the reaction? The second research question was, how does the circumference of a cylinder affect the angle of repose of various materials? Methods. Both investigations required continuous adjustments to the methods used in order to determine the most accurate and doable approaches. Due to time constraints, data from slight methodical variations were used as final data despite not being truly refined. With the first controlled experiment, adjustments were made in all three temperature stages of the experiment. First, at room temperature to determine the initial process, and then secondly, in the heating and cooling stages to determine the best methods of achieving the desired temperatures without tampering with other aspects of the experiment. The second experiment required much less adjustment. Compared to later results, there was an obvious difference in using the funnel than not, and the decision to remove it was made due to a number of reasons, all related to ease of use and obstruction. But other than that, the method stayed mostly the same from the beginning. The data was analyzed in a study in the first experiment using mostly raw data being displayed over graphs, comparing first the loss of mass over time at room temperature between all the trials taken at the room temperature hydrochloric acid Those are then displayed as an average loss at the room temperature. Finally, all of the averages over each temperature have been compared in the third graph to show the relationship between temperature and the rate of reaction. Unlike this first experiment, the second experiment had a lot less data to be compared and was not put into graphs at all, and was only calculated using trigonometry to calculate the angles of repose in relation to the circumferences and the materials used.
Laws and theories. The topic A experiment, the chemical rate of reaction between hydrochloric acid and calcium carbonate, can be applied to a number of nature of science topics. This helps the development of scientific knowledge. Laws and theories are an embedded part of scientific knowledge. As a result, throughout the course of the experiment, laws and theories were used to justify and improve the reliability of the data. The collision theory was evident as it claims with an increase in temperature, there is an increase in energy that can be converted into activation energy in a collision, and that will increase the reaction rate. This was reflected into our controlled experiment as we increased and decreased the temperature of the hydrochloric acid to see how it affects the rate of reaction. This helped the justification for our methods as we realized to keep our data as reliable as possible, we would only increase and decrease the temperature by 5-degree increments. The use of another theory, stoichiometry, helped develop a valid methodology that utilizes appropriate measures of the variables as it helped determine how much hydrochloric acid is needed to react with 50 grams of calcium carbonate. Observations and inferences. Observations and inferences are a critical part of the nature of science. The experiment exemplifies the intricate nature of science inquiry. The experiment showcases how empirical evidence is gathered through careful observation and reliable measurements. This links to Chalmers' work, where he establishes that facts constitute a firm and reliable foundation for scientific knowledge. This leads us to the idea that direct, unobstructed observations are vital. Such observations lead to inferences about reaction rate and how heat affects the speed and time of the reaction. Ensuring validity and reliability of this experiment involves repeated trials and controlling variables such as time and the temperature to identify how these variables affected the initial weight. Additionally, the experiment highlights the importance of objectivity and limiting potential bias. This ensures that conclusions are based on data rather than prepossession. Value judgments about the experiment's significance and implications are based on empirical evidence and logical reasoning. This reflects comprehensive grasp on the nature of science. Empirical basis. The topic B experiment, the angle of repose, utilizes the different natures of science to build the fundamental knowledge needed to understand different forms of science inquiry. The angle of repose experiment uses the nature of science topic empirical basis. The experiment shows how scientific knowledge can have a direct interaction with the natural world. By measuring the angle of repose for select materials, we can engage in collecting quantifiable data that forms an ability to draw scientific conclusions. This experiment reinforces the importance of empirical evidence in validating scientific concepts. The methods we use to ensure validity and reliability are crucial to empirical basis. We kept our experimental environment reliable through a single person completing the accurate measurements and the others completing standardized processes such as pouring the materials and recording data. Repeated trials enhance the reliability of the dataset, allowing for the establishment of consistent angle average. This empirical rigor underscores how scientific knowledge is systematically created and validated through careful, repeatable experimentation. Tentativeness. The angle of repose experiment exemplifies tentativeness throughout the correlational study between the diameter size and the angle of repose. In general, correlations can only suggest that variables vary together in some fashion, not that there is a causal link between an independent variable whose effect we are curious about and the dependent variable presumably affected. Valiala suggests that variables vary together. This can in turn suggest that tentativeness is connected to the idea because as scientists, we claim that scientific knowledge is not concrete. This quote highlights tentativeness by emphasizing that correlation does not establish causation, reflecting cautious interpretation. Methods to control the variables, such as particle size, was taken into account when analyzing the data. We also achieved objectivity through consistent and precise measurements. Making value judgment that aligns with the empirical data on the angle of repose is critical to the reflection and comprehensive understanding of the task. Tentativeness of science is highly evident in the experiment as subject to variability based on materials and the condition of materials. The topic A experiment shows vital reasons why laws, theories, observations, and inferences are a vital part of controlled experiments, and reflects why this topic of science inquiry is interconnected with nature of science. The topic B experiment shows explicit ways of connecting the correlational study to the nature of science topics and the different ways to approach the different scientific inquiry methods.
For ethical understanding, we needed to adjust our methods to respect participants' our health while doing the experiments. It was figured out that pouring freehand controlled the rate at which sand dust accumulated in the air. This was so the person pouring wouldn't be at risk in breathing in the sand dust. Originally, sand was poured through a funnel, but too much sand dust was appearing, so the funnel was lowered to about 10 centimeters away from the top of the cylinder. Lowering the funnel seemed to work, but still too much sand dust was developing. So the method was adjusted again to the freehand pouring method. In the chemistry control experiment, however, only standard PPE use was sufficient due to not any notable risk being present, so there was no need to adjust the method. PPE used were safety glasses, lab coats, and gloves. For social responsibility, the impact of the correlational experiment, angle of repose, on society would be its application of heap leaching and stockpile management in mining and quarrying. The angle of repose of mined materials is crucial for designing heaps with optimal percolation and recovery of materials. Also, the designing of stockpiles for safety and optimization of space. Other societal impacts include landslide predictions and grain storage. For impacts of the control chemistry experiment, calcium carbonate is a common ingredient in antacids. So understanding its reaction is crucial when seeing how it reacts with stomach acid to design effective treatment for indigestion and acid reflux. Hydrochloric acid is also used in industrial cleaning and is used to remove calcium carbonate deposits from boilers and heat exchangers. For our accountability, although the data could be unreliable through human error,